There is a website called DASL. The full form is Data and Story Library, that has many interesting types of data. One of these data sets is about Amazon books. For 325 books, we have 13 variables. Variables are like title, name of the author, the weight of the book, how many pages there are in the book, and the cover type, whether it's a hardbound book or a paperback, etc. So here the data matrix has 325 rows and 13 columns. Now some of these variables are identifier variables like this title and author. Some are continuous variables like the weight. Some are counting variables like the number of pages, while some others are categorical variables like cover type, taking only finitely many values. Now this type of multivariate data is the simplest to understand. The cases and the variables are both quite obvious. Next, let's look at a slightly more involved form of multivariate data, also from the same website, DASL. When we see the world around us using two eyes, each eye gets a slightly different view. The brain fuses these two views into a 3D perception of the world. It is possible to fool the brains using a device called a stereogram, a device which shows two slightly different images of the same object, one to each eye. After some time of staring at these two pictures, the brain feels that it sees a 3D object. This amount of time is called the fusion time. It depends on the image and also on the person who is viewing the images. Some researchers wanted to know if this fusion time may be reduced by telling the person beforehand about the 3D object they were supposed to see, like a floating square in this case. To test this, two groups of individuals were each shown the same stereogram. The persons in the first group were told about the 3D object beforehand, while those in the second group had no idea about what they were going to see. Each person was to press a timer button the moment they started perceiving a 3D object. So we have two bunches of fusion times. Now this may not look like a multivariate data, but it is. Here each person is a case, and there are two variables, the fusion times and the group to which the persons belong. Next we shall look at a third type of multivariate data, which you may find surprising. You may not be aware of this, but when you see a digital photo, it is made of lots of tiny tiles. If we zoom in a lot, then these tiles become apparent. These tiles are called pixels. Here, the original image was 551 by 348. That is, it is a matrix of pixels, 551 columns and 348 rows. So that means we have got 191748 pixels in all. When you hear about a 13 megapixel camera, the matrix is so very large that there are about 13 million pixels in all. Now let's zoom down to the pixels again. Each pixel is a tile of solid color, and each color is made of three components: red, green and blue. This pixel, for example, is made of these three color components. The intensities of each component are from 0 to 255, darkest to brightest. In this case, the intensity values happen to be 70, 38 and 114. Now you may find it hard to believe that these three rather darkish tints add up to make this more bright color. But remember that here we are not talking about painting pictures, but about on-screen images which are made of light emitted from the device. Each of these dark components contributes some amount of light to create a relatively brighter color here. Thus, each pixel means 3 numbers. So, our original image, which had 191748 pixels, consists of this times 3, that is 575244 many numbers. That is values of as many variables. For example, one variable is for the red component of the top left-hand corner of the image. And similarly, another variable is for the green component of the same pixel, and so on. If you take 10 snaps, then your data matrix consists of 10 rows and 575244 columns. In the first two examples, we had n greater than p. In the last, we had p much larger than n. This latter scenario is very common nowadays thanks to digital data collection devices like digital cameras. The methods suitable for the n greater than p case are not suitable for the p much larger than n case. Indeed, a new branch of statistics has developed to deal with the latter type, and this is called high dimensional data techniques. Now, however, in our elementary exposition, we shall restrict ourselves only to the traditional n greater than p case.